Hello and welcome everyone to this 22-minute Tips and Tricks webinar. I'm Jeremy Rignaris, part of the product marketing team here at SOLIDWORKS, and I'd like to spend the next 22 minutes covering a few of my favorite tips and tricks that I've found in my time using SOLIDWORKS. Though not a comprehensive list of all the subtle tips and tricks there are in the software, there's quite a few to cover in the time we have available. So let's quickly go over what I'll be discussing. First, I'll start with the user interface, as the UI is really the foundation for everything we do in the software. Then we'll look at a few sketching tips, as sketches are really the building blocks for all the 3D geometry we create. And finally, we'll look at the three core document types, parts, assemblies, and drawings, and show a few tips in each of these areas that will hopefully save you time in your day-to-day workflow. With that, let's go ahead and dive right in and get started. For this presentation, I'll be using this rotating engine assembly to show several tips and tricks and how they all interact with each other. So let's go ahead and start by looking at the user interface. For this, I'm going to open up one of the connecting rod parts. Now keep in mind, even though I'm working on a part file, everything I'm going to show you in regards to the UI is relevant to parts, assemblies, and drawings equally. Now, one of the things I really love about SOLIDWORKS is the variety of tools I have at my disposal to help me get my job done. That being said, it can sometimes be challenging finding that one button I need out of so many. For example, I would like to use the Move Face command to stretch this connecting rod. A quick glance up at my Command Manager's Feature tab and Surfacing tab, I can see that the Move Face icon isn't there. So how do I find it? Well, I could use the old method of looking through the pull-down menus until I eventually find it, but that wouldn't be an efficient use of my time. SOLIDWORKS actually has a really nice way to find any tool in the software. In the upper right-hand corner is a series of search tools. One of these is called Command Search. All we need to do is select commands from the drop-down list, then just start typing the name of the command we're looking for. In this case, as I type move, SOLIDWORKS presents me with a list of commands that contain that keyword. Once I see what I'm looking for, I can select it right out of the list and start using it immediately. This is a really convenient way to not only find tools, but access those tools you intentionally leave off your toolbars to save space. But what if I did want to add it to a toolbar? That's something I really like about Command Search. Let's go back to that list. As long as a command has an icon next to it, I can add it to any toolbar in the software by simply dragging it and dropping it, in this case to the Surfacing tab. Now, I like using the Command Manager in SOLIDWORKS for the tools I use often, but I really love using the shortcut bar for the tools I use all the time. Some people call this the S key because of the hotkey you use to access it. Now, I've customized my shortcut bar some as to include a few drop-downs, for instance, sheet metal, weldments, and surfacing. But if we take a look at my surfacing flyout, it doesn't actually contain the same tools as the surfacing tab on the Command Manager, specifically that Move Face icon we just added. That's because these flyouts use the standard toolbars in SOLIDWORKS. What that means, though, is we can easily customize them. Just right-click somewhere on the user interface and select the toolbar you want to modify, in this case, Surfaces. Now, we could just add the Move Face button the same way we did before, but I'd like to take this opportunity to show another trick. You can actually move a button from one toolbar to another without even going into the Customize menu. All you need to do is hold down the Alt key and then drag and drop the button you want to move. For example, Move Face. Keep in mind that we're moving the button, though, and not copying it. When I return to my shortcut toolbar surfacing flyout, we can see that the Move Face icon is now there. About those flyouts, I'm often asked how I get them on my shortcut toolbar, and this process is quite easy. With the shortcut bar up, just right mouse click and choose Customize. Now, I'm using SOLIDWORKS 2013 here, and this is a little easier in this version, but previous releases work fairly similar. Here, in this drop-down, you'll see that I have access to all the tools in the software. For instance, maybe I want to add some of these pattern tools from the features list. A better way to manage those might be using a flyout, and if we scroll back up to the top, the first item in the list is flyout toolbars. These basically represent all those standard toolbars I just mentioned, and there happens to be one for patterns. I can add this to my shortcut bar just by dragging and dropping it where I want, and then I can even resize the shortcut bar. And now when I return back to the model, we can see that my feature patterns are available in a convenient pull-down, saving lots of space on the shortcut bar. Let's take a moment to quickly recap what I've shown in regards to the user interface. First, we took a look at command search and how it can be used to search for any command and even add them to the toolbars. Then, we took a look at the shortcut bar and how to customize it and add flyouts to save space. We also showed that we can customize the UI by simply dragging and dropping icons using the Alt key. Let's go ahead and move on now and look at some tips we can use while sketching in SOLIDWORKS. Sketching is a pretty big part of the software, so I want to show examples using this timing sprocket. I find that I really like that SOLIDWORKS tries to help me automatically add sketch relationships. I can see that it's doing this whenever there's a little yellow icon next to my cursor as I hover over geometry. Sometimes, however, I don't actually want to add any relationships. This might be trying to freehand close to some existing geometry like here, or working in a fairly congested part of the sketch. Well, there's a little trick to temporarily turn off the automatic creation of sketch relations. Just press the Control key while sketching and you'll notice the little yellow icon next to your cursor disappears. Now, when I sketch this line, no relationships are added. I can see this when I try to move the line afterwards. Another trick while sketching is to use the grid snap increments. You'll notice while I sketch, the dimension simply changes based on my cursor position. But if I hold down the Shift key, the dimension begins snapping to 1/8 of an inch increments. This is nice if you want to draw a line or a circle to a specific size before you add any dimensions to it. I'd like to look at a few more examples, but I want to show a different sketch for this. I'm going to change to a configuration where the teeth haven't been cut into the sprocket yet and modify the tooth profile sketch. In this sketch, we have 3 circles and we want them all to be tangent and equal to each other. Whenever we select multiple sketch entities, SOLIDWORKS presents us with a convenient pop-up with all the relevant relationships based on what we selected. However, as soon as I add the tangent relationship in this case, the pop-up goes away. So even though I was able to quickly add tangency, I still need to add that equals relationship. A few ways of solving this are going to the property manager on the left and manually selecting equal, or reselecting the geometry altogether. But there's actually a trick to avoid all of this. All I actually need to do is simply repress the Control key and the pop-up returns. Now I can select equal, and even if I wanted, press Control again and continue adding more relations. This is much faster than reselecting the geometry or moving back and forth from the property manager to the graphics area. Now that we've looked at sketch relationships, I want to take a moment to look at Power Trim. It's a great tool to quickly clean up a sketch, but it's so powerful, it's easy to get a little carried away and accidentally trim something you didn't intend. But if you look closely, you'll notice there's a little dot created where I passed over the last thing I trimmed. It's sort of like a little undo tool, and all I have to do is drag back over that point and I can undo the last thing I trimmed. And I can continue to do this as much as needed. Now, Power Trim is a great tool for getting rid of geometry quickly, but it can also be used to extend geometry just as easily. It's slightly different in that all I need to do is select what I would like to extend and then choose what to extend up to. It's a pretty versatile tool that really helps create just what you need. To wrap this up, I'll just cut the tooth profile using Instant 3D and then pattern it using the flyout we added to the shortcut bar earlier. So let's pause a moment and review what we saw in regards to sketching. First, 2 hotkeys to use while sketching geometry. Control temporarily stops SOLIDWORKS from adding sketch relations, and Shift snaps the size of geometry to our grid snap increments. Then, we saw we can add multiple sketch relationships using the pop-up by simply repressing the Control key. And finally, we looked at Power Trim and its ability to undo trim and extend. Now, we're going to move on to some part-specific tips, and to do this, I would like to open the crankshaft used in the assembly. It has some unique characteristics I want to look at. The counterweights in this design are all pretty much the same, and would be really easy to create with a linear pattern if it wasn't for the fact that the middle ones were rotated 180 degrees from the outside counterweights. This is a great opportunity to talk about using multi-body part design. I'm going to open this design in an earlier state to explore this concept. In this design, I've started with a simple cylinder for the bearing surface. Then I've patterned that, and you'll notice in doing so, I've created a part with multiple bodies. In fact, when I did this, SOLIDWORKS revealed a folder containing all the individual solids. Next, I created the journal where the connecting rod attaches out in space, also as a separate body. This method makes it really easy to get the basic geometry created and then just fill in the rest with a connecting geometry, in this case the counterweights. I've also intentionally left the counterweights in the journal unmerged from the bearings, and we'll see why I did this in a moment. But before I continue, I want to show you a feature you actually never have to create. From the height show pull down, I'm going to turn on temporary axes. They're axes that SOLIDWORKS creates automatically on every cylindrical feature, and they're extremely useful, especially on predominantly cylindrical parts such as this, as we'll see in a moment. Here is where multi-body part design really starts to shine. I want to pattern all of the geometry needed for the journals and counterweights, and to do this, I'm simply going to create a linear pattern. The first thing we need to do is specify the direction, and this is where the temporary axes come into play. They're extremely convenient to specify the direction, as there are very few linear edges in this part to select from. Like any other pattern, I'll also specify the spacing and number of instances. Now here's where multi-bodies differ from normal features. In a traditional pattern, I would need to select all the features required to create this. But if I instead expand the bodies to pattern selection, I can choose all that geometry in one go, without any need to worry about which features were used to create it. So we've patterned the counterweights, but that still doesn't solve the problem of the ones in the middle being rotated 180 degrees. This again is another advantage of multi-body part design. For this, I'm going to again use a tool not on my toolbars and use command search to look for a tool called Move Copy Bodies. Move Copy Bodies is a powerful tool that allows us to reposition bodies multiple ways. In this case, we're going to use it for rotation. To rotate about a specific axis, we're again going to utilize the temporary axes SOLIDWORKS created for us. Then we just need to specify the rotation angle, which is 180 degrees. When you're finished with the temporary axes, you can also simply toggle them back off using the same pull down. That's something I really like about them. Not only do I not have to create them, I can show them when I want and turn them off when I don't need them. We're fairly close to the finished design, and multi-bodies made the whole process considerably easier than creating everything with different features and sketches. However, the crankshaft still consists of several disjointed bodies, and we want this to be one continuous solid. If you select multiple bodies and right mouse click, there's a tool available called Combine. This tool allows you to perform different Boolean operations. All we're interested in right now is Add, which merges all the geometry together. And as soon as I did this, the Solid Bodies folder disappeared, letting me know there's only one solid in this file. Before we move on, I want to look at two other tools for manipulating both feature-heavy and imported parts. I want to remove the hole in just this one counterweight. There's no easy way to go back through the history of the part and modify this one instance. Also, if this were an imported part, we wouldn't have that as an option. Traditional ways of doing this would be to simply fill it in, but we need to preserve these two contoured surfaces as well. This is where Delete Face comes in handy. We can select any faces we would like to remove, right mouse click and choose Delete Face. Delete Face has an option called Delete and Patch that will preserve the surrounding geometry, and when I apply this, we can see that the contoured surface was filled in properly. The other example I wanted to show is the Move Face tool we added to the Surfaces flyout earlier. Move Face is very powerful when you just want to make a change without modifying the history, or again if you were working with imported data. Just window select all the faces you want to move, and here I need to make sure I've got the inside too as well. And once I've done that, I can simply use the triad to move all this geometry just by dragging it. And all this was done without digging through the feature history. We spent a decent amount of time on parts, so let's review. We discussed the benefits and a few concepts regarding multi-body part design. We saw that features like patterns can leverage multi-bodies, and Move Copy Bodies can be used to manipulate them. Then we looked at Delete and Move Face, two great tools for manipulating geometry on complex featured parts and imported geometry. Now we're going to move on to my favorite part of SOLIDWORKS, assemblies. The first thing you might notice in this assembly is it's meant to rotate, but if I try to move the crankshaft, nothing actually happens. This is actually because I designed the piston and connecting rods as a subassembly. Though, you'll notice I've captured all the relevant motion here in the subassembly. In fact, when I return to the top level assembly, you can see that all the parts have moved accordingly. However, this is definitely not an ideal way to look at motion in this design. If we look at the assembly tree, we can see that some of the piston and connecting rod assemblies have a slightly different icon. That's because these have a unique property. They're set to what SOLIDWORKS calls flexible. To make a subassembly flexible, all you need to do is select the assembly and choose Properties from the pop-up menu. There's an option in the lower right-hand corner called Solve As, where we can change between rigid and flexible. This option allows any motion in the subassembly to be honored here at the top level, and now that I've done this, the whole assembly moves as intended. Yet, I've retained the subassembly structure I desired for design purposes. I now want to show several ways we can assemble components in SOLIDWORKS. I have a part that needs to be added to this assembly, the crankshaft positioning sprocket, which I'll open in its own window. And to make things a little easier, I'm going to tile my windows and then isolate the crankshaft so we can see where the sprocket needs to be assembled. SOLIDWORKS allows you to not only drag and drop parts into assemblies, but if you drag on certain types of geometry, such as a circular edge, SOLIDWORKS will actually mate them together when you drag it into the assembly. This was done automatically using something called Smart Mates, and you can actually do this at any time you like by simply pressing the Alt key and dragging and dropping. For instance, I'll do this by holding Alt and drag this face on the crankshaft keyway to the corresponding face on the sprocket. SOLIDWORKS automatically knows I want to add a coincident mate. All I have to do is confirm this. Now, when I rotate the parts, we can see they are fully mated together. Another way to locate multiple instances of components is to reuse existing patterns. In this case, I need 2 of these bearings on every bearing on the crankshaft, and if we remember back to that part, the bearings were created using a pattern. I can quickly create multiple copies of these using feature-driven component pattern. SOLIDWORKS places a copy of each bearing at each pattern instance. It's not only fast to place the components this way, but if I change the bearing pattern in the crankshaft, such as the quantity or spacing, this component pattern will update automatically with it. But what if I already have some components mated together, and I would like to add more of them and repeat the same steps that I did to place them? I'll turn on a washer and bolt I've added to the bottom of one of the connecting rods, and we can see that I need to add several more. Copy with Mates is great for this. All I need to do is select the parts I want to copy, right-click, and choose Copy with Mates. Then, I just select geometry similar to what was used to mate the originals, such as this tapped hole and this face on the connecting rod, and then just right-click to confirm. It's really convenient when I have to do this over and over, and I can even move the assembly through its range of motion while doing this. It makes this whole process considerably easier than adding each one of these components one at a time. Though probably the longest tip I've shown, you can see that the process is pretty simple. Select the hole, then select the face. Right-click and repeat. Before we know it, I've placed 14 components with little effort. Now, I want to get to the drawing tips and tricks, but before we do, let's do another recap. Flexible subassemblies allowed us to reuse the motion of a subassembly in a top-level design. Then, we saw that we can not only drag and drop a part into an assembly, but mate the components at the same time. This was done using Smart Mates, which we learned we can do at any time using the Alt key. We also saw that we can reuse patterns from our parts to locate component patterns in our assembly. And finally, we saw how easy Copy with Mates makes it to place lots of copies of an already mated set of parts. Now, let's finish up by going over some drawing tips and tricks. This is probably most users' favorite area, or rather most time spent area in the software. And for this, I'm going to start by just creating a drawing of the piston assembly and start by placing a view. After we place the first view, SOLIDWORKS automatically makes sure that all my views stay aligned, like this top view. But what if we didn't want a view to be aligned this way? When we place a view such as a section view, we can see that it is in fact aligned to the view it was created from, but we might actually want to move it somewhere else. Well, this can be done while you're placing a view by holding down the Control key, and SOLIDWORKS will allow you to freely place the view anywhere you like. But what if I wanted to align this view to another view to keep things tidy? You can align views at any time by right-clicking on a view and choose Alignment, and in this case, I'll align the section view to the top view. And you can always go back and choose to either break the alignment or set it to another view, such as its original parent view. Now, I want to look at one of my favorite things we can do with views in SOLIDWORKS. I'm going to create a half section through the top view, and though this makes a nice view by itself, I want to show something really cool. To get a better understanding of this view, it might be convenient to look at this in an isometric section view. To do this, you can select any view, and in the heads-up display in drawings, there's an option to rotate it. You can even choose predefined views and models like isometric. Then, if I click the OK button, the view will be saved in this position. Now, the line work in this view doesn't look that good, and this is the second part of this trick to make these look nice. We want to go into View Properties and set the option Hide Cutting Line Shoulders. And while we're here, let's do one more thing that really makes this view stand out and make it easier to understand. Section Scope is a way to selectively choose which parts get cut in the section view. In this view, it might be easier to understand if we choose the circlip and piston pin. And when I press OK, the view's lines are all cleaned up, and notice the circlip and piston pin are no longer section. That's a pretty nice looking section view. I want to show two more things, and to do this, I'm going to add a second sheet. I want to create a view of the whole assembly, and SOLIDWORKS allows you at any time to add views from other files. In fact, it even gives us a drop-down list of files to choose from that are open. So I'll select the top-level assembly and place the front view. When you're working with moving parts, sometimes you want to show them in a specific position on a drawing. This is a great use for configurations. To change a view's configuration, we need to go to the View's Properties again. In this design, I've created two other configurations than the one we've been working on. The first is called 90 degrees and shows the crankshaft rotated 90 degrees from top dead center, and the other is top dead center itself. For reference, top dead center is when piston number 1 is all the way up or extended depending on how you want to look at it. When I choose top dead center, SOLIDWORKS will redraw the view using this configuration, regardless of where all my parts were in the configuration we were working on before. This ensures that all my components look nice on the drawing, but I can also dimension them much easier this way. But what if I wanted to show those two different positions, top dead center and 90 degrees, I just mentioned? This is where alternate position views comes in, and is definitely another favorite of mine. When you choose to create an alternate position view, SOLIDWORKS will give you the choice to either create a new configuration on the fly or use one that already exists in the assembly, for instance the 90-degree configuration I just mentioned. SOLIDWORKS then creates sort of a silhouette of the 90-degree configuration over the top of our existing view. And once we create an alternate position view, we can even dimension between the two different positions, like these pistons for example. This is a great way to show motion in a static 2D drawing. Let's again recap everything we looked at in regards to drawings. First was breaking the alignment of views on the fly using the Control key. Then we saw you can actually rotate any view in 3D. We also learned you can exclude components from a section view using Section Scope. Then on the second sheet we saw you can use configurations to lock down parts in a drawing, and finally alternate position views can be used to show multiple configurations at once over top of each other. Well, that's all I have for today, and I'd like to thank everyone for attending, and I hope there was a little something for everyone that they might take away and benefit from. But before I get into the Q&A, I would like to mention, if you like what you saw today, local user group meetings are a great way to see lots of content like this on a regular basis. To learn more about local user groups in your area, check out the SOLIDWORKS community page on the SOLIDWORKS website.